Hi everyone, this is example 14. An orifice 152.4 mm in diameter having a coefficient of contraction of 0.62 discharges oil under a head of 7.468 meters. The average velocity at the center of the orifice is 7.193 meters per second. So determine the coefficient of discharge, the coefficient of velocity, and the frictional loss. The frictional loss is also the head loss in the orifice. So take note that this given average velocity occurs at the center of the orifice, not at the vena contracta. So since the coefficient of contraction is found, then we use this coefficient of contraction to determine the diameter at the vena contracta. Then knowing the diameter of the at the vena contracta, we can use continuity equation that discharge through the center of the orifice is equal to the discharge at the vena contracta, which is the actual discharge. So from there, we can equate it to Kautog to compute for C. Then after that, knowing the velocity at the vena contracta, we can compute C sub V from actual velocity is equal to C sub V square root of 2G times big H. Then the frictional loss is head loss is head times quantity 1 minus C sub V square. So that's the flow of this solution. So first, as I said, we compute for the diameter at the vena contracta. So 0.62 equals pi over 4 diameter at the vena contracta square over pi over 4 diameter of the orifice 152.4 square. So pi over 4 is cancelled. So it's just diameter at the vena contracta square over 152.4 square. So diameter at the vena contracta is 120 mm. Then since Q through the orifice is equal to the actual discharge also by continuity equation for liquids, so pi over 4 diameter square times 7.193 is also Q. So 152 pi over 4 is not shown already, times 152.4 quantity square is 7.19 times 7.193. This is supposedly pi over 4 or Q through the orifice is equal to pi over 4 120 square actual velocity at the vena contracta. So the velocity at the vena contracta, which is also the actual velocity, is 11.6 meters per second. So from there, we can compute the actual discharge area at the vena contracta times actual velocity. And we equate it to Kautog. So pi times radius at the vena contracta is 0.06 square. Then actual velocity 11.6 equals Kautog. So C pi radius of the orifice is 152.4 divided by 2 is 76.2 mm or 0.0762 square, and square root of 2gh. So we can now solve for C. Coefficient of discharge 0.5942. The next is the actual velocity is C sub V square root of 2g times h. So 11.6 equals C sub V times square root of 19.62 times 7.468. So we can also compute C sub V. Then finally, head loss, frictional loss is head times quantity 1 minus C sub V square. So head loss is 7.468 times 1 minus 0.9583 square. So the head loss is 0.6098 meter. So that's it for this problem.